In this video, I want to talk about a few important definitions that are necessary for us to understand more and more complex electric circuits. So let's just go through the definitions one by one, and I have this sample circuit to the right. So for each one of these definitions, I will mention what exactly each of these definitions means more visually. So the first definition that we have already seen before is the definition of a node. A node is a point in the circuit where two or more circuit elements join. So if you remember from before, we said that the ideal basic elements that we usually use usually have two terminals. So let's just say we have this resistor, or let's just say we have this inductor. I call this L, right? So as you can see, each one of these has two terminals. So if for example, I connect these two terminals together in my circuit, you can consider this wire that connects these two together, or I would say this point that connects these two together, to be a node. Of course, let's say if I change the orientation for the resistor, so let's just say I put this horizontal, and also let me just change the orientation of the inductor and make it like this. So now terminal 1 is here, terminal 2 of the inductor is here, right? And I connect them. So as you can see, the orientation of these components does not change the node that connects these two together. So let's just say we want to take a look at this example picture that we have here. Let's just see if we can identify the nodes that we have in this circuit. So we have here an independent voltage source that is connected to this resistor, R1. So the point that these two elements are joined together, we call it node A. Now we have here, for this node, we have R1, R5, R7, and this independent current source being all connected to this point, right? So you see that we have these additional wires, but since there is no extra component in between, for all intentions and purposes, these are all connected, right? So for node B, as you can see, unlike node A, which only had two components connected to it, for node B we have four components, R1, R5, R7, and this independent current source. What about node E? We have node E, which basically connects R3, R5, and R6. So as you can see, node is a point where two or more circuit elements join. But even in this very basic example, you see that there are nodes that more than two circuit elements join. So because the concept of nodes are, I would say, too generic, it is good to define more specialized nodes that can help us reduce the number of equations that we need to solve when we want to solve this circuit. So that's why we have the definition of an essential node, in which essential node is a node where three or more circuit elements join. So for this circuit, we have 1, 2, 3, 4, 5, 6, 7 nodes. But out of these 7 nodes, how many of them are essential nodes? So let's just go through them one by one. So is node A an essential node? The answer to this question is no, because A only connects two elements together. So A is not an essential node. What about B? So B connects 4 elements, R1, R5, R7, and this current source named I. So B is going to be an essential node. What about C? Again, C is an essential node because it connects 3 components together. So C is an essential node. What about D? D is not an essential node because it only connects 2 elements, R2 and R3. What about E? E is an essential node because it connects 3 elements, R3, R5 and R6. So we have E. Then F. F is not an essential node because it only connects 2 elements. And finally we have G, which is an essential node because it is the point of connection of 4 elements, R4, R6, R7 and this independent current source. So out of the 7 nodes that we have here, only 4 of them are essential nodes. Okay, so now let's just go to the third definition. We have the definition of a path. So a path is a trace of connected or adjoining basic elements with no elements included more than once. So let's just come up with a couple of paths. So one path that I can think of is the path of V1 and R1. So I can show it like this. V1, R1, it creates a path. So there are 2 elements that are connected and none of them is accounted for more than once. So that's one path. Let's just think of another one. What about R2, R3, R5, R7 and I? That's a valid path. So we have R2, R3, R5, R7 and I. So if I want to draw it, it would be something like this. So even though this might not be a very useful path, but it is a path nonetheless. So as you can see, for this circuit you can come up with many different paths. The whole point is that all these elements need to be connected. So you cannot have a path including R2, R3 and R4 only. You can have R2, R3, R6, R4, or even you can have R2, R3, R6, R4 and V2, right? That's valid. Even though it's a closed path, but it is a path nonetheless, right? Because you didn't count any element more than once. But the whole point is that all the elements in the path should be connected. Okay, so now let's just go over the definition of the branch. So a branch is a path that connects 2 nodes. So any 2 nodes that you find in this circuit that are basically adjacent, the line that connects the 2 is considered a branch. So let's say we have node A and node B. So we have R1 to be a branch. What about node C and D? So R2 is also a branch. What about node A and C? So V1 is a branch. So what about nodes C and E? Is the combination of R2 and R3 a branch? So the answer to that is no. So as you can see, a branch is another name for a circuit element. So let's go to the next definition. What is an essential branch? So an essential branch is a path which connects two essential nodes without passing through an essential node. So as you can see, the definition of an essential branch is a little bit more involved than a branch. So a branch was basically a circuit element, but an essential branch is a path that connects two essential nodes. And also, this path should not go through an essential node itself. So let's just say we have B, C, E, G as the essential branches. So we have B, C, E, and G as the essential branches. So the essential nodes. So what is the essential branch that connects B and E together? So the answer to that is R5. So that is, you can say, is an essential branch. So even though it's only one component. What about the essential branch that connects C and E together? Of course, you can say V1, R1, and R5, but that doesn't count because R5, this branch goes through node B. So it says that it shouldn't go through an essential node. So it will be R2 and R3. So let's just show it that R2 and R3. So that is the essential branch that connects node C and node E. What about the branch that connects C and G? So this branch is V2 and R4. What about the essential branch that connects B and G together? So obviously we cannot go this path. Why? Because it goes through C. We cannot go this path, for example. Again, it goes through E and C. We cannot go this path. It goes through E again, right? But you can go through R7. So R7 is practically an essential branch. What about I? Is I an essential branch? The answer to that is yes. So you can say between B and G, you have two essential branches. And so on and so forth. You can do it for other ones as well. For example, for between E and G, and I think that's the only one that is left, right? But definitely take a more closer look and come up with all the essential branches that you see in this circuit. So now let's go to the next definition. We have the definition of a loop. A loop is a path whose last node is the same as the starting node. So let's just write down a few of the loops that we see in this circuit. So I write it here. I just say some of the loops. I don't want to write all of them. So is this path starting from F going through V2 and then R2 and then R3 and then R6 and R4 a loop? The answer to that is yes, because we start from F. We go through all these 5 components and we end up back at F again. So we have V2, we have R2, we have R3, we have R6, and then finally we have R4, and we are back where we started. So that's a loop. What about V1, R1, R5, R6, R4, and V2? Is that a loop? The answer to that is also yes, because we start from node C, we go to V1, we go to R1, R5, R6, R4, and V2. So that is the definition of a loop or a closed path. So now, based on this, we can define the concept of mesh. So a mesh is a loop that does not enclose any other loops. So that is very important. So for loop, for example, the second loop that I just defined here, as you can see inside of it, you can have two loops, right? So this larger loop has two smaller loops inside. So a mesh is basically a loop that does not enclose any other loops. So if I want to write the meshes that we have here, so we have V1, R1, R5, R3, and R2. So that's one of the meshes, V1, R1, R5, R3, and R2. What about V2, R2, R3, R6, and R4? Is that a valid mesh? The answer is yes, because I start from F, go around this path, this loop, and then I end up at the same starting point. And also, there is no other smaller loops inside of it. So that is a valid mesh. So what about R6, R5, and R7? R6, R5, and R7. Again, this is a valid loop. And finally, we can have a loop that contains R7 and I. As you can see, this is a loop as well, because you start from a point, you go around the loop, you end up at the same point, right? You didn't repeat any of the components more than once, and then there is no other loop inside of it. So that is a perfect mesh. So as you can see, in this circuit, we only have 4 meshes, but we can have more than 4 loops. And then finally, the definition of a planar circuit, which you are already familiar with. I went over it in a previous video. So a planar circuit is a circuit that can be drawn on a plane with no crossing branches. So now that you know all these definitions, you should be able to identify the node, essential node, path, branches, loops, mesh in any circuit that you are given, because the definitions are very straightforward. And based on these, we now have a good foundation to move forward with solving more complex electric circuits. So in this video, we went over some important definitions: nodes, essential nodes, paths, branches, essential branches, loops, meshes, and finally planar circuits.